it's one thing to say, oh, we're an AI first organization. It's another thing to actually breathe it and live it from the top down. Using AI tools is a great start, of course, but then using it and then just saying we're going to throw this as part of your yearly KPIs, like how much AI you're using. I think that kind of misses the point. Because one thing that humans are incredibly good at is being very inertial.
Hey, welcome, Sairam. Great to have you on the podcast. Really like to talk to you about artificial intelligence today because I know you've recently written a book about that. And I think if I got it rightly, that's about how people can learn AI. Is that correct? And if so, how would you recommend that people go about learning AI?
So thanks for the introduction, John. I'm delighted to be here. So yes, the book is called AI for the Rest of Us, and the rest of us is kind of tongue in cheek, to be honest, because in my career as an engineer to an engineering manager, the thing I've noticed is there's a disconnect between the business side of the company and the engineering side of the company, and it's almost always something to do with translation, where the business side is trying to explain why something is not giving enough ROI, is not going to be a profit, center. It's going to be a cost center. The engineering side is going to try to explain why something is or isn't feasible in technical terms, and they're just trying to solve the problem, but not speaking the same language. So the rest of us, for me, is the people in the messy middle who need to understand AI, not so that they can fine tune or train a large language model, but be able to understand it enough technically so that they can explain and translate, be the bridge between the different sides of a company, and everybody rows in the same direction as opposed to competing. So that's what the book is about. It's explaining how AI works in plain English, with as minimal jargon as possible, because AI is a field that absolutely adores abbreviations, jargon, and whatnot. So now coming to the second part of your question, so how to learn AI? I think that question has different answers depending on when one was getting into the field. I think a few years ago it was more clear cut. You had to go and understand a bit of linear algebra, some basic calculus about how derivatives work, and then of course you'd be well off knowing some kind of programming, whether it's Python or, and then you'd sort of build the blocks together and train some models. And today it's like there's so many things you can learn in AI. So the first question is, what do you want to learn? And then how do you want to learn it? So there are different sections within AI, right? So there's the AI engineering side, which I define as people who use models to build software systems and applications. They're not the ones who are actually training the models, but they're using the models that have been trained for them. But they need to know systems and system design, and it's a completely different skill set. And then you have the people building the models. They need to build models that are efficient, that are aligned, safe, with user preferences. And then there's an entirely forgotten branch or subsection of AI, like computer vision, for example, or recommendation systems, which nobody seems to talk about these days because LLMs are all the hype. And I hate the fact that people call generative AI, the field of using LLMs to create something. It's not true. Like, what about generating images or videos or like there's so many nitpicks I can do. But I digress. So we have to pick a bucket. Where do you fall? And then within that bucket there are different ways to learn, but I guess the common thread in each of those buckets is start using things, start building things. Don't be stuck with theory. Learn theory as you go. So if you want to start with, say, being an AI engineer, you probably want to start building a system that solves a problem that you have, like scratch your own itch. And then you're going to figure out, oh, hang on a minute, I don't know how to do this thing. And then nowadays we have the convenience of Claude and ChatGPT and Gemini. Just ask those models, okay, so I need to understand this. Can you explain it to me? And then that is a theoretical reinforcement. Of course, these models hallucinate. So you want to make sure you're getting the information from well cited sources. But that aside, you're sort of having this feedback loop where you're building things and then you're learning about them along the way. And regardless of whether you're training a model, whether you're using that model, or you're working in a forgotten part of AI, that to me is the best approach to learn. So start doing, less reading, and then read as you build. That would be my suggestion.
I love that. I'm very much pro learn by doing. That's my whole thesis with coding challenges and so on. And I've put up several times posts arguing that the best way to learn a programming language is to read just enough of a book or tutorial to get started, and then start. And then when you get stuck, go and I used to say Google it or read about it. As you say, nowadays with an LLM, you can go and ask the LLM for some prompts.
Yeah,
But learn by doing, I absolutely agree. And it's just as applicable for learning a programming language, doing system design,
absolutely.
becoming a better writer or better communicator, or learning AI. And I am totally with you on the subset of AI. I have found myself infuriated over the last couple of years. And I've been attacked for being an AI cynic for a lot of the last couple of years because I've been quite outspoken about the hype of AI. Because I've been interested in AI for about 40 years now. And the field has changed massively. 40 years ago, the focus was expert systems and was logic, was optimized search. A little bit later than that, it was evolutionary algorithms, genetic programming. Then there was talk of fuzzy logic, there was expert systems, there were things like ELIZA. And then it progressed throughout the decades. Neural networks were talked about in the late 80s, early 90s, but the computers were so slow. We didn't have the data sets to train them on. And then, as you say, we got later into rebranding it as machine learning because AI was a dirty word after the AI winter. As you quite like to point out, we've had computer vision, all these different subsections. And then there was a great paper published at the end of the 90s, written, I think it's titled, "As Soon as It Works, Nobody Calls It AI." I think that goes back to a quote from John McCarthy, one of the early forefathers of AI. And it's so true. There are so many things that we use nowadays that we just call software. We just use them. We don't talk about them. And they were AI 20 or 30 years ago. They were viewed as, in many ways, the way that LLMs and generative AI is now. So that's why I've pushed back against the hype. Equally, though, LLMs are incredible and generative AI is incredible. It's amazing what we can do. And we shouldn't forget how incredibly good recommender systems are. Go back, was it about 2010? Netflix offered $1 million prize.
$1 million for the best
for their recommender system. That was a big deal. Everyone talked about that. It was really hyped up. Now we just use it. Everybody uses Netflix or Amazon or whatever and gets their recommendations of what to watch next and doesn't think about it. Nobody talks about it. Again, computer vision is used all over the place and we're not really talking about it. It's just, you use it and get on and build your system.
Yeah.
So it's really interesting how much we've forgotten how. And again, even 10 years ago, deep learning was the next big thing. Everyone was doing a deep learning startup, and generative AI is just a subset of deep learning, which is a subset of neural networks, which is a subset of the whole massive field of AI.
Yeah.
So it's really interesting how much we've shrunk the world down as everyone's focused on one tiny subset. I do feel sorry for any researcher that's working in a different part of AI and kind of getting ignored and not even treated like it's AI anymore.
Yeah, it's like I'm noticing this in the job market as well. Like I pretty much every other resume I come across, it's some generative AI. I do RAG, I build agentic systems. It's like, hang on, do you know how to train a model like a basic level? I'm not even asking for training a GPT or anything. Just something. Do you understand how loss functions work? Do you like? It's just incredibly difficult to find that. Oh, but I do know how to prompt and I can get a real tune out of this GPT model. That seems to be the flavor of the day. So
Yeah.
completely with you on that. And then everything is called AI. That's the other, the other side. It's like AI is now a blanket term. It used to be a dirty word, but now it seems to be a blanket term, right? Everything, you just tack on some kind of LLM to it, and now it's an AI powered product or what have you. So
Yeah, it's interesting that, and I've worked with AI several times throughout my career. Shipped some AI products to the likes of Apple and Facebook in the past. And yet, when I spoke to somebody the other day, I went, "Oh, do you worked in AI?" Yeah, I've spent about 15 years of my career doing AI. Oh, so you built lots of agents? Nope. It's mostly been other stuff. Agents are just a tiny bit of what's recent. Yeah, it's interesting how much that world gets zoomed down to one little bit that's focused on. And I'm sure in a couple of years, we won't be calling it AI anymore. It'll just be some chatbot interface that you use somewhere.
Yeah, yeah, absolutely.
Much as it's having a major impact on software engineering and it's sucking in a lot of investment capital.
Hmm.
Once we get past that hype, it'll settle down. We'll find some good use cases for it. We'll find a lot of the use cases for it are perhaps not as exciting as they thought to be. And maybe we'll go back to exploring some of those other interesting areas.
Yeah. To be honest, like I feel um, part of the hype seems justified. Like you said, there's like incredible things you can already do. I mean, if I just rewind 2 years ago and think of what was possible then to what is possible now, the progress has been mind-boggling in some areas, and so rightfully so, there is a bit of hype around it. The thing is, like, people need to zoom out and look at the bigger picture and think about AI holistically versus AI being just about one thing, because the flavor of the day keeps changing. The fundamentals or the core principles don't change. So I guess that's what people seem to be missing.
Yeah, and it's interesting how LLMs have suddenly been this major step, and everybody's hyped about AGI. Where I was hugely impressed about 2010 when we started to get deep neural networks that could take voice and actually transcribe it really well.
Hmm.
We've had people trying for decades to do good transcription and struggling. We made major breakthroughs with that, and same for some of the computer vision and being able to look at text and not
Right.
just do OCR, but do then the translations. But a lot of that never quite made it out of the geeky field. Google was doing a lot of research, different people were, and I read about it and saw some of it, and I was like amazed at how well Google Translate could work. But that never quite got the same hype, even though I think in many ways it's almost as impressive a technology.
Yeah. And it's impressive because it just blended with the product or the system, right? You never really thought about using something in addition to the system. It was just intuitive. You just used it, and then suddenly your experience using that thing improved. And like, oh, no, this is nice. This is pleasant, and on your way. So
Yeah, absolutely. So people use dictation software, or they started speaking to Alexa or Siri, and they didn't really think about it. Or, I mean, for me, the one that most impressed me was Google Translate. Being able to take my phone and hold it over a menu in a foreign country. So, look over a menu that's in Thai and have
yeah,
it immediately tell me what that says in English. I thought that was truly fantastic, and was a bit surprised it never quite got the excitement and the breakthrough that it had for
yeah.
everyone else, because there's some real solid use cases there. We're still struggling for a lot of the current market to figure out a good use case for LLMs.
Hmm.
I mean, they are incredible for building software, and for what the technology really is. It's incredible how good they are at building software. Beyond that, I don't know that we've really found a killer use case for it yet, despite trying really, really hard. I don't know. Have you got any ideas what that might be?
Well, it's difficult, right? Because again, there's like just being able to write software by speaking in English seems very strange. It's a very surreal experience for somebody who's, you know, I've previously like sat for weeks trying to implement something and then test it. Then now it's like, oh, just go and implement this, and then okay, run some tests. Is this working? And then just being able to orchestrate versus actually, roll up your sleeves and have to write everything. That to me is already a killer use case. Um, Writing has improved as well. I mean, of course, I don't want to generalize it. I'm not talking about AI slop where you just prompt it and then copy whatever it throws at you. I'm actually talking about very tactical writing where you can do things. If you are diligent, you can actually do things like look up your favorite writers, see how they write, deconstruct their writing with the help of LLMs, understand what makes the writing, sing for you. And then because for each of us we have a different set of preferences, and then if you can deconstruct that and then see how you can find your own voice from there, being able to articulate points in a way that is not just correct but is also creative. I feel like there's a lot of potential that is to be tapped there, as opposed to just saying, oh, I just use this writing tool, I'll just give it a bullet point list or a voice transcript and have it, chuck out a 2000 word essay. I feel like that's losing the point. And to me, the other killer use case that isn't used yet is, in fact it's being used the wrong way, is to really test your ability to ask the right questions. And I say this with a particular reason in mind. If you think of education, right now it's probably the greatest time to be alive if you are a student, because any subject you have a patient 24/7, 365-day teacher who's always available to you, ready to teach you what you want. And I feel like the solution has been misused, where if you're given an assignment, the first thing is you throw it into ChatGPT and ask it for the answer, and then you just parrot it out and you're turn it in, right? But that's missing the point. You're outsourcing the thinking. I actually wrote about this in my newsletter, I think a couple of weeks back. And the example that I used is, imagine that you're visiting this amazing mountain. There are two ways to get there. You can either climb from the base camp. It'll be very difficult. There's a lot of obstacles along the way, and by the time you reach to the top, you'll be tired, but you would have, you'll see the full perspective. Or you can just take a helicopter and just go to the top, and you'll still reach there. You will see the beautiful result, but you have no idea of the other perspectives involved. And should some trouble comes, like some snowstorm or whatever, right, you have no way of getting back down, right? So both people arrive at the summit the same way, only one arrives transformed. And I feel like 90% of the people are actually the helicopter folks who are just landing on the top, just using it for very shallow purposes, outsourcing their thinking. The 10% are the folks who are actually using it to sharpen their thinking. And that to me is the killer use case that hasn't been tapped.
Yeah, I agree. I've been working with a few people to go through and demonstrate how they can leverage LLMs for building better software. And I see an awful lot of people still just using it as autocomplete, or going along, as you say, with that very shallow prompt of write a function to do X. Or they're coming along with that even worse little thing of build me a clone of Y. And it's that one or two sentence input and then expecting that it's going to do an amazing job. And I think every time I see that, if you are outsourcing the thinking, yes, the LLM can generate code, but it's taking an input, that input context we give it, and it's predicting some output context on that. That is all it's doing. So if your input context is really, really vague, you should expect a vague output. You have to still do that thinking. You can't just outsource that thinking to it and assume that it's going to guess what you wanted when you haven't even thought about what you wanted. Because it's not a mind read, and even if it could read your mind, you're going, well, I want a clone of Y. And it's not enough detail enough. So even if somehow it magically learns to read your mind, you still have to have that clarity of what you want. And as you say, we can go in there and we can use it to help achieve that clarity. I think one of the most underrated things that I'm seeing people not do is don't go along and say, here's my question, give me the answer. Go along and say, here's what I want to achieve, here's my goal. What are the questions I should think about? Or what questions would you ask me about that? And as you say, turn it into a dialogue. So either ask it to explain the steps of something to you. So I want to learn about quantum mechanics. What are the building blocks I need? Get it to give you that journey and guide you through it. Or say, well, I want to do something. What are the things I should think about? And get it to, again, even if it hallucinates, it doesn't really matter if it's 10 or 15% wrong, because the 80% that's right will give you some sort of paved path you can follow, won't it? Something that you can then dig into, learn more, Google, read a book, or whatever to expand your horizons and become aware of more things. So,
Yes, like for example, one of my favorite things to do is anytime I want to understand a code base, I just um, highlight a section and I say, "Can you explain why this has been implemented this way?" And can you explain, or if I see a new construct that I'm not familiar with, I ask, "Okay, so what's going on here? What's this thing?" And it's amazing how much you can learn, and then the follow-up question is, okay, so how could we implement this differently? Why has it been done this specific way? What are the trade-offs here? Just levels of thinking that you can go into. It's amazing how much you come out transformed from that kind of a conversation versus saying, okay, what is this line doing? Or is it a bug? Fix it. Then go on. That's not going to get us anywhere. So the I don't know if you've seen the movie Wall-E, the
a
Pixar
while
movie
back,
with
yes.
the, yeah. So do you recall the very spoiler alert, but do you recall the last scene where the humans finally land back on Earth and they see this plant and their mind is blown? They've completely forgotten what it is, and they rediscover it. They've just been so lazy, doing having robots do everything for them. It's kind of like that. That's what I'm seeing at a smaller scale happening now.
Yeah, absolutely. And again, I saw that on a training course recently where an engineer just said, well, a LLM produces like 100 or 200 lines of output. It's tedious to read that. I don't want to check it. That's, where an LLM had produced that or a person have, your job has always been to read that and understand it. We communicate in writing, whether it's writing documents or whether we're writing code. And whether a human or an LM wrote that, your job has always been to review it. You still have to do some thinking. You talked there a little bit about digging in and getting it to explain a function. One of the criticisms about LMs for software engineering has always been a lot of people saying, well, it works on a POC, it works on something tiny, but it can't cope with a big code base. And you can't do maintenance or bug fix with it because it won't cope with a large code base. I'm not sure. I don't want to put words in your mouth, but from what you've just said, I wonder if you would agree with that.
I think the answer is depends on two things. First of all, the model that's available to you, because if you have something like the Opus 4.5 or Codex, that to me feels like a leap in what is possible versus what was possible. The other aspect is if you don't engage with the design, like the design document or say a PRD, you're not spending enough time thinking through how to design good software, because the thing that hasn't changed is good software engineering principles. The thing that has changed is how you achieve the outcome while still respecting these principles. And so for me, it's both an art and a science, because you need to figure out how to prompt these models to produce the kind of code that has that robustness to it. And it is possible, but again, you have to be incremental about it. You still shouldn't forget about tests. You should also think through about edge cases, security. All of those things are still absolutely valid, like you said. But what is changing is, instead of us having to write every line of code, we're just getting this superpower of being able to write a few or maybe 100 lines at once. So it's kind of like having this long rope. So we need to make sure that we don't let the rope go all the way out, because then it's difficult for us to understand. Whereas if we sort of keep it in increments, where we're incrementally developing, testing, I feel like you can do a lot more than people give credit for. And one other point is, yes, these models do have a tendency to over engineer sometimes. So if you have rules and guardrails placed at the start, like your cursor rules or your Claude MD file, there's amazing things that you can do that are very consistent with how the rest of the code is. I'm not saying it's perfect yet, but the way to think about it is these models are only going to get better, right? And so you need to sharpen your skills in terms of building very good, for nose for smells, code smells, and also just being able to just think like an architect versus somebody who's just a junior engineer who's writing code. So that's how I feel about it. I feel like the answer is somewhere in the middle. It's a lot more is possible than before. But if you're going to vibe code your way and just imagine that things are going to work, then you're in for disappointment.
Yeah, I completely agree. My view of it has been that arguing that it doesn't work with a large code base somewhat misses the point, because I don't work with a large code base. None of the software engineers I've ever worked with in my life can look at a million lines of code, remember what it all does, and know where it all is. What we do is we filter, we search. So if you give me a million line code base and ask me to fix a bug or to add a feature, I'm going to reach for grep and search through the code base and try and find where seems to be the relevant bit of code. Then I'm going to forget about all the other bits I've seen along the way, and I'm going to focus on that bit of code and try and understand that. So I liken that with when you're using an LLM, you have a context window. If you fill it with, here's all the million lines of code, then yeah, it's going to be completely lost and it's going to have no idea where it is. If you focus down and say, like, I've found that we're going to add this feature and it's in this file or these two files, and this is the relevant bit, and this is the API or data model you're going to call, you're giving it a narrow constrained task. And it can do perfectly fine there. It doesn't matter you've got a million line code base or 10 million line code base or 100 line code base. You've given it the very narrow context that it's got to work in. And I don't think that that is any different to what I do with an engineer on my team. Right. If I'm mentoring an engineer that joins my team, when I've been a CTO or a VP or a senior software engineer, when I've got somebody that's new to the code base or somebody that's junior and that needs that help and that mentoring, I don't say, here's a million lines of code. I say, right, for this ticket, here's how we find it. This is how I'd approach it. And this is what we've narrowed it down. It's in this area of the code. So look at these two files and understand those. Come back and ask me for help if you get stuck. So I'd guide them and focus them and give them, a small area of context of the code that they're going to focus on for the ticket. I think if you do that for an LM, there's no reason why it can't tackle a big code base, just like you're somebody that's new to your team or a junior engineer. No reason why they can't do it if you give them that little bit of guidance and don't just throw them in at deep end with a million lines of code to figure out. To tie back to what you said, you mentioned on the writing, I love that you said you can pick apart your favorite authors. You can recognize what they do that makes it, bring that to your own style. We can apply that to coding too. If you want the LLM to build code in your style, do that analysis, then give it some good examples and say, here are 3 examples of how I want you to write, this function or this test, write in this style. So yeah, I think that's a great approach that a lot of people aren't doing. So they should steal that from you. And whether it's writing their next book on AI or writing the next bit of code, take that technique. Sorry, you were going to say.
No, I was just going to add to your point about context bloat, right? I mean, there's now you have subagents, and if you know how to use subagents, you can delegate a whole bunch of things like documentation, unit tests, and other things in parallel without bloating the main chatbot's context, right? It's amazing how many things you can accomplish with subagents, and like I said, this is like an art and a science. You're learning to write code, right, in air quotes, in a completely different way, and so it's a new interface, but the principles haven't changed. It's just you who have to change with to maximize the benefits of this new interface.
Yeah, absolutely. So we talked a lot about AI and software development there, but you also mentioned earlier on we've got AI engineers and model builders, and they're really interesting to me, that split between business and tech. How do we start addressing some of that gap where we have somebody building a model has a very different understanding of AI to somebody who has downloaded Google's ADK or downloaded Copilot's Copilot SDK and built an agent on top of that, where realistically they're using an API and it's calling a REST API at the back end and it just happens to generate some text from a prompt. They're not really doing AI, they're leveraging a framework. How do we kind of cross that divide so they can start understanding each other a little bit? And again, talking to the business people, talking about what's viable, what's doable, how reliable it is, and say thinking about which model do we pick. Well, let me give you a use case maybe to apply that. So if maybe we're an airline and we want to integrate a LLM into our website so we can provide useful information to people,
Hmm.
how do we go about pulling together that team? Is you're going to have the AI engineer who's building an agent. You might have a model builder who's contributing to fine tuning this, or maybe you're going to build a custom LLM or introduce some RAG or something. And then you've got the business person who says it's going to do all these amazing things, while those of us that know how to build it are having a bit of a heart attack saying, well, it can't really do those things. It can't be deterministic, and we can't guarantee that it's 100% going to do X, Y, or Z. How do we address that challenge of the different language they'll speak and the lack of knowledge and build those bridges that you mentioned earlier?
That's a multi-layered question, and I'll do my best to answer that. So, thanks for the example, by the way. And just, I think there was a recent situation with Air Canada, if I'm not mistaken, where their chatbot gave wrong information to a customer for a refund policy, and then the customer didn't get the refund, so they sued, and all this kind of thing erupted.
Yeah.
So,
Shamelessly, that is my
it's
inspiration for this story and this
okay.
scenario.
Okay, so I think at the very outset, right? It's a big part of being on the same page is cultural. I feel, because it's one thing to say, oh, we're an AI first organization. It's another thing to actually breathe it and live it, from the top down. Everybody, like, using AI tools is a great start, of course, but then using it and then just saying we're going to throw this as part of your yearly KPIs, like how much AI you're using. I think that kind of misses the point. Because one thing that humans are incredibly good at is being very inertial. So if you've been using a tool or a process for years and years, it's going to be very hard to get you out of it, because your brain doesn't want to think. It just wants to automate everything so that it can focus on what it really cares about, which is survival, right? So so basically, if you've been using Excel for 20 years, you're going to find it very hard to actually use a chatbot and then start doing those things slightly differently. So the first is cultural transformation. It has to underpin any technical stuff that goes on. I'm not saying the technical stuff isn't important, but if you really want to see ROI, the transformation has to be cultural first, and that takes time. And that means that people share their learnings in a company in a common forum. That means that maybe the company organizes hackathons where different entities of the business come together and they work on a small POC, and then they see how it works, and then they see how it breaks and it doesn't behave as it would. And then that, by doing small things like this, you're actually making people unlearn and relearn certain hardwired habits, and that's the first bit. The second bit is the translation, which I mentioned. So, the book, obviously, it's like, I wanted to solve this problem. And when I wrote the book, agents and RAG weren't a thing. They are by the time the book came out. But I focused on sort of the fundamentals and the more or less evergreen things versus the cutting edge, or rather just focusing only on the cutting edge. So yes, you'll learn how ChatGPT works, but you'll also understand what existed before ChatGPT. So the point here is, you need to speak the basics. Like, if your engineer comes and tells you, yeah, the KPIs are looking good, or and then if you say, oh well, the model's got 90% accuracy, and your engineer comes back and says, no, that's a bad metric, we have an imbalanced data set, you should be able to understand that the engineer is telling you that your one of the classes in your data has like got a very large number of examples, the other one doesn't. And so if you just rely on accuracy, you're screwed. So just being able to make that connection, right? Those kinds of that level of understanding is crucial. And you have chatbots to help you learn, so there's literally no excuse, right? And then the third bit is actually using AI on a regular basis, building things with it, because we're kind of writing a user manual as we go. There isn't a well-defined user manual for most of these things, to be honest, because every time somebody discovers a unique way to prompt one of these models, and then that becomes the trend, everybody wants to use it. But then there isn't a standardized way. And the other thing is, these are probabilistic. They are not going to give you the same output if you prompt it the same way twice. So just coming to grips with that reality. This is especially true for the AI engineering side, because the modeling side, I mean, it's easy to point fingers and say, you guys built a crappy model, it's not reliable. But you have to understand that these are guessing the next item that comes in a sequence of items. So they are guessing. That means there's probability involved. So just understanding that, and then building heuristics and guardrails around it, and then speaking with your colleagues who are building these models, like saying, oh, I'm seeing this happening in production, we put this out, the model's hallucinating a lot, what do you think we can do about it? Is there something in the modeling side? Can you guys train this better? If I give you some examples of how it failed in production, can you maybe fine tune the model better, or can you do some other things that will make it more reliable? Just having that open dialogue where you are explaining your challenges, and on the reverse side, the modeling folks might say, you guys wanted a lower latency model, so we had to make this, we had to quantize this model down. By quantizing it, the accuracy or the metrics dropped, and so that's why you're seeing poorer performance, that's why the model's hallucinating. Just channels of communication, and then being able to like absorb certain technical nuances through osmosis just by interacting with your colleagues. So I feel like that is the key, at least one of the keys of to truly build AI systems that delight customers. I hope that covered some of the ground. I know there's a lot more layers here, but I'm going to stop there.
No, I think that's great because you've highlighted that common saying that we have that everything boils down to being a people problem, and AI is not changing that. You've highlighted that we have that inertia, and that the first thing we need to change is the people and the culture and how we approach that. And doesn't matter what the technology is, doesn't matter what the domain is. It's always we've got to address the people things first. It's always a people problem when we get down to the nitty gritty of it. And that inertia is something I want to pull out again. There were people saying, I don't know, 6, 12 months ago that in 6 or 12 months, software engineering is dead. Everyone will be using LLMs to code and nobody will like software anymore. And I've been very critical of that. I think it's complete rubbish. And at the same time, I believe that LLMs can be a great tool for coding. And a lot of people seem to struggle with the idea that I can hold the viewpoint that it's complete rubbish and they won't be 100% adoption, and that they can be a good tool. And I think the difference that a lot of people are missing is, we've both got a bit of grey hair. We've been around this industry for a while. We've seen that there's that inertia. It doesn't matter how good something is. It takes a while for people to change. As you mentioned, 20 years in Excel. It doesn't matter if we go and present somebody for, hey, this great LLM can do what you've done it. They've got 20 years of muscle memory in Excel. They're used to doing their pivot tables or their sums and their columns and whatever things they can do in Excel. They're comfortable in it. It takes a lot to change people. And it takes even more to change groups of people and whole organizations. And again, if you look back at the history of business, go back and look at some of the businesses that were touted as the titans and the demonstrations of a great business 30, 40 years ago. Most of them are gone. And they've gone because businesses are really slow to change. Businesses are slow to adapt. They have that inertia. And that's the same reason I think no matter how good LLMs are, there's going to be that inertia. It's going to take a while for anything to change. Doesn't matter how good the technology is.
Yeah,
So yeah,
absolutely.
I completely agree.
And
That's
just
really got to be the first thing that happens.
And just a point to sort of further complicate things, I feel like the roles in a company are blurring now. There's no longer a clear split between what an engineer should do, what a product manager should do, what a manager should do. What does a program manager do? Like there's you have all of these roles that were defined for the software engineering era. I mean the traditional software engineering era, and now because of these models, like everybody is able to do a little bit of everything. I'm not saying to the same degree as the people who have spent years honing that craft, but the point is, it's like a rising tide is lifting all the boats, and you're able to do many things that you were not good at while being able to do the thing that you're very good at a very elite level. So just being cognizant of that is crucial, because now I feel like there's like it's time to change, but I want to be really careful when I say this, and I don't want to sound like I'm saying, okay, software engineering is dead. It's not. But the point is, there's more expected of you, because the table stake, what used to be things that you were very good at have now become table stakes, and now you need to figure out what elevates you, what makes you the software engineer for the next era, if you want to think about it, or what makes you the
So
product manager for the next era.
I have a slightly different view on that. So I have a view that software engineering is coming, maybe it's not quite the right word, coming back into fashion. So when I started as learning about software engineering as a career, and when I did my computer science degree, and they talked about software engineering on that, software engineering was everything from somebody says, hey, build this bit of system, this software, to you physically deliver it, because it was a physical delivery in those days. So that meant as a software engineer, you did requirements, you did program management, you talked to stakeholders and customers, you did analysis, you did design, you did infrastructure, you did building the software, doing a test plan, doing a delivery plan. You went for acceptance testing with a customer. Quite often in those days, we then physically delivered something. So, maybe if you're Microsoft, you were shipping, shrink wrapped floppy disks. Some of the things that I delivered were software on a physical system. So, we delivered a couple of tons of physical hardware with the software on it, and plugged in some, old 10BASE-T networking cables, and, a disk array that weighed like 50, 60 kilos and probably cost $1 million in those days. So I, in a way, feel that software engineering is having a resurgence. We're going back to that now, where it seems that more recent people joining the field have thought that software engineering is writing code. To me, software engineering was all those things involved in delivering a system. And now we're coming back to that. We're realizing we have to write specs and requirements. We have to do a little bit of program management or orchestration and figuring out what are the steps, how do we break things down. So slightly different view of it, but to me it feels like it's coming back.
I think it also depends, like you said, on the time that people enter the industry, right? So the practices, the prevalent practices at the time are what stay fresh in your brain, and you always compare what's happening with what was. So for me, there was these separations of concerns, right? There was like clear roles and responsibilities, and of course you had to write specs, of course you had to write design docs, but in terms of if you follow agile, you'll have a scrum master, and that's a completely different person. You're supposed to tell them what you're going to do for a given day, what you'll do in a sprint, blah blah blah. So all of that is changing again, and maybe it is going back to its roots, like you said, because maybe it's just going back to uh, the start all over again, which is
I
quite
think
interesting.
I think in some respects it will be different, because again, when I started, most of us were building software either for a shrink wrap product, Microsoft was selling Office on floppy disks, or we were building software for a large enterprise or a customer. So we'd go and deliver, here's your free servers that cost you $1 million each, and here's your software that we've spent, has cost you $3 million to build or something. So there were big projects that took years, and it was a big thing where we have a very different world nowadays. Nobody is building software like that because, again, it's crazy. There were all the problems with waterfall. It was difficult. It generated a lot of upset. It's now far better to do continuous delivery, and it's far better to build in small increments and work that agile way, which is why we have the Agile Manifesto and the push towards trying to leverage that and fit in with the realities of the world. We also now have, nobody buys Microsoft Windows on a CD or floppy disk anymore, Microsoft Office on floppy disks. You download stuff off the internet or you use a SaaS platform. So everything has changed a lot in there. But I think we're still going back to hopefully picking some of the good bits from the old ways of working and keeping some of the good bits from the modern way of working and being, slowly evolving and becoming slightly better as an industry. I wanted to pick out two of the things you mentioned there. One is AI first. So bearing in mind the inertia we talked about and the fact that it is a people and cultural thing, what does it mean to you to be AI first? And how can an executive lead from the front and make their organization AI first?
So for me, it means that from a product perspective, first of all, it means that that AI is the heart of the product, that AI is vital for that product or service to deliver the outcomes that you promise to your customers. And it's not something that's stacked on, it's not something that's a nice to have, it's a must have, because without it, the entire thing would fall apart. So that's sort of the anchor around which I think about AI first. And a good way to think about it is, if I didn't have AI in my product, in my company's product, can I still get the job done? I can. I mean, like, if you think of a mailing client, it's very easy to still send emails. You don't need AI to auto compose or do any of that stuff. You could argue that spam filtering is probably important, but even then, you could still send and receive emails. It's your choice to, right? Whereas if you think about a chatbot like ChatGPT or Claude that needs to answer you in context with, understanding the nuances of the questions you're asking, you take out the brains from that, you take out the LLM from that, you're left with nothing. You're left with something that's going to probably do keyword matching and give you something that's outdated or not helpful, right? So that's the first bit. In terms of an executive driving this, I think it's very, very hard, right? I mean, you think about their perspective, they're under a lot of pressure. Their competitors are all adopting AI in different ways. They're saying, oh, here's an AI powered feature we just released. Stock prices seem to be tied to anything you say with regards to
Yeah.
AI. And then investors are asking you questions, oh, why aren't you doing when X, Y, and Z are doing all these AI initiatives? So they're under a lot of pressure, and for them, all of this is, for some of them, not all of them. Some of, like, this might be very alien. Like, hang on, this thing can is supposedly able to do amazing things. So why aren't my team doing this? And then the again, this goes to education and understanding. And to be honest, like, you have to invest time to learn and understand the field. I will caveat it by saying it's almost impossible to keep up with what's going on. Even if you are in the pinnacle of AI research, it's nigh impossible to keep up with everything that's going on in the field, because it's just accelerated at a ridiculous rate. But it is possible for you to keep up with what's happening in your area of interest to a certain degree. And you need to invest time daily to spend time understanding what's happening. This can be either through reading books. I'm saying this for a reason, because there's a lot of AI slop, and if you ask a chatbot these days to cite its sources, it will cite that's the slop that was uploaded to the internet. So the models are learning from their own output. So I say books because there's and books that are properly published, because there is a level of thoroughness and fact checking that's gone into it, so you can at least trust the fundamental ideas there. Then you don't need to read papers. You can give it to a chatbot and ask it to explain it to you, like, why is this paper trending on social media, why is everyone talking about it? You can listen to podcasts. There are some fantastic podcasts that educate you on what's going on, explain the happenings. And it's about investing maybe 30 minutes a day. If you can spend 30 minutes a day just educating yourself and keeping up with what's going on, I feel like that puts you ahead of 99% of others who aren't doing this as an executive. And the other aspect is starting to use AI, right? Like, this can be as simple as taking notes in a meeting. This can be maybe using one of these like chatbots for solving certain tasks. Like, if you have a certain workflow that you do by hand, maybe replace one part of it with AI and see, oh, how does it do it differently? What could I have said differently, or instructed it differently to achieve the same type of outcome that I usually get if I do it myself? And then by sort of putting this into practice, you just start thinking, okay, so if I were to use AI, this is how I would use it. And then you also can try some ridiculous things. Like, if you think AI can't do something, challenge that assumption. Actually ask it to do something and be proven right or wrong. And that enables so many things for you as an executive when you are strapped for time, because you're spending your days in board meetings and you have barely any time to uh, think about other things, right? So spend time on certain activities like this. That would be my suggestion.
Cool. I love that we're back to learn by doing.
Full circle, right?
So I agree with you on books, and particularly in an area like this, make sure they're published by a reputable publisher. Doesn't guarantee they're going to be perfect, but at least they'll have put some effort into it. I know there's one well-known book around AI that apparently the authors have said they vibe coded the book.
Wow. Interesting.
I'm not sure how good the book is. I'm not impressed so far from what I've been through. I also would offer a real note of caution on papers. Back 15, 20 years ago when I last had access to an academic library and all the papers, I thought papers were a great source of information because they were nearly all in peer-reviewed journals. They'd had that peer review and they'd be cited and criticised and addressed and all the good things you get from peer review. Unfortunately, these days it seems to learn a lot of public repositories of papers. Yeah. It's very, very easy to publish them. While there are still many excellent papers, there's also quite a lot of junk that's getting published.
Yeah.
And there was one put out the other day by a 14-year-old school kid that started getting cited in major newspapers, and it was just complete junk that produced. There was another one last year where somebody, I think, had produced the entire paper with an LLM, and they'd done it as a joke, and they'd shared it with somebody they knew. If I got them rightly, as a joke. Somehow it got shared with other people who didn't realise that it was a joke, and then it went viral. So the original author was like, this was just a joke between friends. It wasn't supposed to be shared, and now people are quoting it. So you have to be very careful, I think, these days with papers. And
fair point.
What's the source? Is it a legitimate one? Is it peer-reviewed? Are the people writing it credible, known, or are they a 14-year-old kid in their back bedroom that's been doing it for a bit of a laugh? Which is a shame, and it's really hard to judge. And even then, there are some papers where they may have been from a legitimate source, but they can still be bad science.
In order to get into conferences, sometimes there's this urge to, tweak the numbers so that the results are in your favor, or maybe not share code that can exactly reproduce the results of your experiment. There's a lot of these subtle things that happen that kind of undermine the quality of some work, even if it is from a notable source, and that is unfortunate.
Yeah, I was probably more thinking of the ones that are spam and deliberate junk, or people that have done as jokes that people still misinterpret and misconstrue. But yeah, there's an element of that too. It's part of, unfortunately, the academic market of publish or perish, isn't it? That academics are forced into having to play the game to some extent too. Awesome. We have run out of time, so I should give you a life back. Is there anything final that you'd like to say? Any final points you'd like to make?
Well, I just want to say it's been a delightful chat, and I've learned a lot just having this conversation with you, and it's been so much fun. And if people are interested, my book AI for the Rest of Us is available wherever books are sold. So you can find it on Amazon or Barnes and Noble or anywhere else. It's published by Bloomsbury, so you can also hop on the Bloomsbury website. And if you are interested in learning more about AI, I write a weekly newsletter called Gradient Descent, and I'll be sure to share the links with John so that he can include them. So, just delighted to have this chat with you, John.
Yeah, likewise. It's been an absolute pleasure. I've learned a lot from it too. And as you say, we will include links to your book, your newsletter, and yourself on LinkedIn, if that's cool, so people can find you and follow you. We'll put all that in the show notes for anyone who'd like to get in touch. Thank you very much, Sairam. It's been an absolute pleasure.
My pleasure. Thank you so much.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.